Hello, class. We're about to start sections 4.3 and 4.4. And section 4.3 is on pages 418 to 419. And the problems are 1 through 15 odd. So I'm going to pick a few problems that I'm going to do today. So we're going to do problem number 1, problem number 5, problem number 9, problem 13, and also 15. Okay, these are the problems we're going to cover. So starting with problem number 1, we have negative 4x is equal to negative x squared plus 12. Now we're asked here to solve the quadratic equation numerically using tables of x and y values. Verify your solutions graphically. Okay, so what we could do is this here. First thing I would like to do is get all this in standard quadratic form. So what we need to do is add x squared and subtract 12 on both sides. So we will have x squared minus 4x minus 12 equals 0. Okay, so now, with this being said here, what we would need to do is find a value that would basically make this equation equal to 0. So basically, we want to, when we put this in our equation, in our calculator, we could do it like this. If we put y equals 0, okay, that would be one line. Okay, right here we have y is equal to 0. And then our next equation will be y is equal to the x squared. And let me get a better. X squared minus 4x minus 12. Okay, now let's get a better visual here. Okay, now our solution is where these two values intersect at. They intersect here and also here. Okay, so basically our solution would be, and we would just write out the x values. X is equal to 6, and then also x equals negative 2. Okay? Now they did ask us to use a table, but if we do a table, we will put in those values and we would get 6 and negative 2. All right, so our next problem would be number 5. We have x squared plus 12x plus 11 equals 0. Okay, it says in exercises 5 through 8, solve the quadratic equation graphically using at least 2 different approaches. When necessary, give your solutions to the nearest hundred. Okay, now, they asked us to use 2 different approaches. Okay, one approach we could use is what we just did here. First, this is already set up in standard quadratic form. So, what I didn't explain with 1, let me explain with number 5. If you set both sides, y equals to both sides, then we could easily find out the answer by the intersection points of them on a graph. So once you set it up in standard form, you would set y equals to this side and y is equal to the other side. So we would have y equals 0 for 1. And then we would go down here and we would have y is equal to x squared. And then plus 12x plus 11. And all we have to do here now is find their intersection points, which is here. So our intersection points are at x is equal to negative 11. And then also x is equal to negative 1. Now that's one approach. Another approach is we can actually do a table and we could just put in points and see what happens. But another approach is we can actually solve this by first doing the factorization of this quadratic equation and then setting it equal to 0, which I will go over now. Okay, now remember, standard form of a quadratic equation is ax squared plus bx plus c. All right. So here we will list our A is equal to 1. And remember, it's the coefficients. B is equal to 12. And C is equal to 11. So now, after we list this, we will multiply our A and C value. So we'll do A times C. So that'd be 1 times 11, which is 11. So now what we're supposed to do is take the prime factorization of 11 and find two numbers that multiply together give you 11, but add together will give you 12. So A times C is 11. So you will find two numbers multiplied together give you 11, but also will give you, when you add those two numbers, must give you what B is equal to, which is positive 12. And we already have that here because 11, the only factors of 11 is 1 and 11. So 1 times 11 is 11, and 1 plus 11 is 12. Okay, now that we have that established, what we do with these two values here, we substitute these two values in for the coefficient of x. So we will have x squared plus, we have 1x, and then plus 11x, and then plus 11. We're going to leave the, well, I could put the equal 0 at the end. Okay, so now 1x plus 11x is still 12x, so we really haven't changed the problem. So now we get into grouping. We group the first two values and we group the last two values. X squared and 1x, you could factor out an x and you'll be left with x plus 1. 11x and 11, you could factor out a positive 11 and you'll be left with x plus 1. Now the key thing is these two parentheses must be the same. If they're the same, that means that this is factorable. If they're not the same, that means that either you did something wrong or it cannot be factored. So we would take one of these two, which would be x plus 1, and then everything that's on the outside, we will put it in its own parenthesis. So the factorization of this is x plus 1 and x plus 11. So we'll set both of these parentheses equal to 0. And then solve. Subtract 1 on both sides. And x is negative 1. Subtract 11 on both sides. And x is negative 11. Which is what we got up here when we put it in the calculator. That's an alternative method. Okay, next. The next problem would be problem number 9. Now, problem number 9, it says solve the equation by using either a numerical or graphical approach. And I'm pretty sure that most of you would want to use the graphical approach. So we know we will have y equals 0. And then we will have y is equal to x squared plus 2x minus 3. All right. So now we look at their intersection points with each other. And we notice here that we will have x is equal to negative 3. And then x is equal to 1. And that is our answer. Now, sometimes they actually, what I should have been doing, and I made this error, so I just want you all to go back and do this here. It's only been 2 problems. Instead of a comma in between these x's, I should have wrote the word or. So instead of the comma, it should be the word or. Okay? So it should be the word or. Well, let me write that. X equals negative 3 or x is 1. That's because either answer would work. So remember, it was supposed to have the word or instead of the comma. Okay. All right, so now we have that cleared up. Now we go to problem 13. So problem 13, it says, in exercise of 13 to 14, solve the given inequality using a graphing approach. So we have x squared minus 4x minus 1 is less than 11. So what we would do here, we would do this a little differently than what we did before. Okay. So instead of having this equation equal to 0, we're going to set both sides of this inequality. We have y is equal to, one side would be 11, and then the other side would be the actual equation. So we have x squared minus 4x minus 1. Okay, now what we would do here, we will find the points where they intersect. If you notice, they intersect here at -2 and 6. So what we would do, we would write -2, we'll write the lowest number first, the highest number last, and in the middle we will put x here. So x has to be greater than -2, but less than 6. And this is your final answer. All right, so, and of course you could test it. If we put in, for x, if we put in 0, if we made x 0, because 0 is greater than -2, put in 0, this would be -1, which would be less than 11. So 0 works. Okay, let's try the number 5. 25 minus 20 is 5, minus 1 is 4, and then 4 is less than 11. Okay? All right, so, and if we go outside that, what we could do is here, since we do have this equation, we can make this into a table, just to show this to you. And we could just type in some numbers to test this theory here. So we could type in, let's say something smaller, -3. You notice that's larger than 11, which we don't want. We could try 1. 1 is less than 11, which is what we want. Whatever we put in for x, as long as it's less than 11, then that means that it's correct. So here we could try 5. We could try, that's still less than 11, 5.9. That's still less than 11. But when we type in 6, that gives us 11. We want something less than 11, so 6 does not work. And that also goes for -2. So that's a way of you being able to do it as well. So now the last problem is problem 15 from this section. So problem 15, it says the stopping distance d in feet for a car moving at a velocity speed v miles per hour is modeled by the equation. D of v is equal to 0.04 v squared plus 1.1 v. What is the stopping distance for a velocity of 55 miles per hour? So basically all we would do here is just substitute in 55. So it'd be d of 55 is equal to 0.04 times 55 squared plus 1.1 times 55. Now, once you put this in your calculator, d of 55 will be equal to 181.5 feet. Now it says here, what is the speed of the car if it takes 200 feet to stop? Okay, so now with this problem here, now this was A. Now we're getting into B. Now we would take that equation, 0.04 v squared plus 1.1 v, but this time we would set it equal to 200 because they told us what it would take to stop. It would stop at 200. So now we can do what we did before. We could subtract 200 on both sides. And 0.04 v squared plus 1.1 v minus 200 equals 0. So we could go here and make this y equals 0. Then the next one would be y is equal to 0.04 x to the second power plus 1.1 x and then minus 200. Okay, now we need to look at their intersection points. Let me scroll back here. Now the intersection points here are, I'm going to write them down. It's where v is equal to negative 85.79. We're around the two decimal places. Or v is equal to 58.29. Now, did they say round to the nearest? Okay, they didn't say round to the nearest mile. So these are approximations. Okay, now here's the problem. When we're looking at this, we're talking about miles per hour. We know we cannot have a negative miles per hour. So this right here would not work. So our answer here with this velocity would be approximately 58.29 miles per hour. So that would be the final answer. And that's actually the last problem from section 4.3. Now we're going to go over here to 4.4, which starts on page 425. And we're supposed to do problems 1 through 21 odd. So now, what I'm going to do here, I'm going to pick out a few problems. We will have 1, 7, 13, 17, and then 21. These would be actually the problems that we would do. All right. So let me start off with problem number 1. And this is on page 425. It says in exercises 1 through 4, factor the polynomial by removing the GCF. Okay, so number 1, we had 12x to the 5th, and we know GCF means greatest common factor. So we had 12x to the 5th minus 18x squared. So we look first at the coefficients. 12 and 18, the highest value they have in common is 6. Then we look at the variables, x to the 5th and x to the 8th. The greatest common factor they have is x to the 5th. Now the parentheses is what we have left. So whatever we factor out, you have to take the original values and divide it by this here, what we factored out, and that whatever's left goes inside the parentheses. So 12 divided by 6 is 2. The x to the 5th simplify out. Negative 18 divided by 6 will give us a minus 3. X to the 8th divided by x to the 5th is x to the 3rd. And that is the final answer. Okay, that's number 1. Now we go here to our next number was number 7. Number 7, we had x squared plus 7xy plus 10y squared. It says completely factor the polynomials. Remember to look for the GCF first. So we go through all 3 of these terms, and we see if we have a GCF besides positive 1. X squared, 7xy, and 10y squared only has positive 1 in common. So that means that we would have to go through, and remember how we did the standard quadratic equation is ax squared plus bx plus c. Now, if you look here, this looks a little odd because we have an x squared, an xy, and a y squared, but it's still set up in the same way. So a is 1, b is 7, and c is 10. So we multiply a and c, so that'll be 1 times 10, which is 10. We take the prime factorization of 10, which is 1 and 10, and 2 and 5. So we have to find two numbers multiplied together that will give us 10, but added together would give us what b is equal to, which is 7. So that would be 2 and 5. So we replace 7xy with the 2 and 5. So we have x squared plus 2xy plus 5xy plus 10y squared. Now we group the first two. We can factor out an x, and we add x plus 2y. We will group the second two, and we can factor out a positive 5y, and we will be left with x plus 2y. Now remember, these two parentheses must be the same to let us know that this is factorable. So we would take out one of these parentheses, x plus 2y, and then what will go in the second parenthesis is what's left, which is x plus 5y. And we are done. Okay, next. Our next problem would be 13. So we have problem 13. We have 20b to the fourth minus 65b to the third minus 60b squared. Now remember, we must take out our greatest common factor first. 20, 65, and 60 all has 5 in common. B to the fourth, B to the third, and B to the second. B to the second would be their greatest common factor. Now, 20 divided by 5 is 4. B to the fourth divided by B squared is B squared. 65 divided by 5, a negative 65 divided by 5 is a negative 13. B cubed divided by B squared is B. Negative 60 divided by 5 is negative 12, and the B squares will simplify each other out. Now, we have our 5b squared. Now we look here to see if we can factor this. So we would go off to the side and list our a, b, and c. Our a would be 4, our b would be negative 13, and our c would be negative 12. So we'll multiply a and c. So we have 4 times negative 12, which is a negative 48. Now we want to write out the factors of 48. Now listen, when we write out the factors of 48, we're not going to put the negative sign for right now. We're going to just do it as if it was positive 48. So we have 1 and 48, 2 and 24, 3 and 16, 4 and 12, let's see, and 6 and 8. Okay, these are all the factors of 48. Now, what we have to do is this. Remember, we have to find two numbers multiplied together that will give you negative 48, but added together will give you negative 13. When your b is negative, that means that the larger number or the larger factors all will be negative. So when we add these together, it's whichever one gives us negative 13. This will be negative 47 when we add. This will be negative 22. This will be negative 13. So 3 and negative 16 is what actually works. So now we're going to just concentrate on this parenthesis, and we'll bring down the 5b squared later. So we have 4b squared plus 3b minus 16b minus 12. Now we group the first two. We can only factor out a b, and we have 4b plus 3. We group the second two. Now this is important. Whatever sign the first value of the second two has is what you would factor out. So since this is negative 16, whatever we factor out must be negative. So negative 16 and negative 12, the greatest common factor is a negative 4, and that will leave us 4b plus 3 when we divide both of those by negative 4. Now if you notice here, both of these parentheses are the same. So we'll write that 4b plus 3. And then what's left on the outside, the b minus 4. And then we would be done, but remember, we had this 5b squared. So we'll bring down the 5b squared And now we're done. And that is it for problem 13. Now we move on to problem 17. Problem 17. We had x squared minus 5x is equal to 14. It says solve each quadratic equation by factoring. So basically they're having us do the same thing except for we would solve this time. So first thing we would do is subtract 14 on both sides. So we have x squared minus 5x minus 14 equals 0. So right now what we're going to do, we're just going to concentrate on this side with the quadratic form. So here we see if we got a greatest common factor besides positive 1. We don't. So we would list our A, B, and C. Our A is positive 1, our B is negative 5, and our C is negative 14. So we'll multiply A and C, so it'll be 1 times negative 14, which is negative 14. Now, what we have here, we have to take the prime factorization of 14, which is 1 and 14, and 2 and 7. Now we look here at B. B is negative, so that means that our larger factors are negative. So this would be negative 13, and this would be negative 5 when we add them. So we know the 2 and negative 7 is what we would use. So we add x squared plus 2x minus 7x minus 14 equals 0. We group the first two. We could factor out an x, and we add x plus 2. We group the second two. We could factor out a negative 7, and that will give us x plus 2. So both of these parentheses match up. We'll write them one time. We add x plus 2, and then we add x minus 7, and that equals 0. So now that we have our two parentheses, we'll set both of them equal to 0, and then solve. So we add x is negative 2, add 7 on both sides, and x is 7. So our final answer would be x is negative 2 or x is 7. Okay, now the last problem would be problem 21. So problem 21, and it's under the same directions. We have 3x times x minus 6 minus 5 times x minus 6 is equal to 0. Now, what's nice about this is already set up to where we got here. You notice that both of the parentheses are the same. So we'll write that down, x minus 6, and then what's left will go in the second parenthesis, 3x minus 5. And we'll set that equal to 0. So x minus 6 is equal to 0, and 3x minus 5 is equal to 0. We'll add 6 on both sides, and x equals 6. And then we will add 5 here on both sides, and 3x is equal to 5. Divide each side by 3, and x is 5/3. So our answer here would be x equals 5/3, or x equals 6. And that is basically it. But I want to do problem 19 as well. Let me just do problem 19, and then we will call it a day. Problem 19. We have 3x squared minus 12x equals 0. Now, we don't have anything to subtract because we already got 0. We already have this equal to 0. But the greatest common factor of 3x squared minus 12x is 3x. And then that would end up giving you x minus 4 in a parenthesis. So then you would take 3x equals 0 and x minus 4 equals 0. Divide each side by 3 and x equals 0. Add 4 to both sides and x equals 4. So your final answer would be x equals 0 or x equals 4. And we are done with section 4.4. And if you have any questions, feel free to contact me. Have a wonderful day.